In this video, we're going to go ahead and cover section 10.3, ellipses. This is still part of unit 10, topics in analytic geometry. Excuse me. So let's go ahead and get started. We have our definition of an ellipse, and this is the set of all points x, y in a plane, the sum of whose distances are two distinct fixed points, which are kind of like two focuses, which we call foci for plural, and that's constant. We have two axes for this one. We have a major axis, which is made by 2 points, also known as the, or you can also think of it as two vertex points. And the line that goes through these 2 points also intersects the focus, or the two focus points that we have, also known as again the foci, which is plural for focus. The middle part of this line is known as the midpoint, and that's the center of the ellipse. The minor axis is the opposite. So if you have and you'll see a picture right now, if your major axis is going this way, your minor axis will go the opposite way, and it will be perpendicular to the major axis. Again, you have that the plural of focus is foci. And here's a picture of what this kind of looks like. An ellipse kind of looks like an oval, what you might remember from geometry. And again, here are the two vertex points, or the vertices. Your focus will be the same distance from the center. And again, that's going to be located on this major axis, the one that's bigger. The minor axis will be perpendicular to the axis, and it's going to be across the other way. Okay, so here I have a space down here that I actually kind of labeled, I guess you could say. You have these two x points, and what I'm going to show you here, hopefully it comes out okay, is exactly what the focus represents and how you can actually create an ellipse out of those points. So what I have here is just a random piece of string. I'm going to actually, this works better with two fingers. I'm going to just kind of hold on to this here. Hopefully it works okay. And to create an ellipse, what you do is you kind of pull this string and just kind of go around like this. Yeah. And you'll notice that if I were to keep on going around, went off a little bit there. If I were to keep on going around, which I probably can't do so well here, but something like that. If I were to keep going around, this part over here would connect at some point. And that is how an ellipse is created. Mine's a little crooked, but basically this would be kind of like our major axis. This would be the minor axis. Mine went off just by a little bit. But these 2 points right here, this is our focus points. And there's 2 of them. So it's the foci, and they are equidistant from the center, just like our previous subunit on parabolas, where it was equidistant from the directrix to our points on the parabola, just like it was to the focus. Okay, but anyway, I just wanted to show you that. There's actually an activity you could do with this if we were on campus, maybe next year. Yeah, maybe my students next year will get to do it. You get to actually do this physically, so it's kind of fun. But anyway, let's go ahead and move on to our more set of notes. We have some stuff to copy here. The standard equation of an ellipse, again with the center HK. So we still have our center HK, and major and minor axes of length 2a and 2b respectively have the following format. So if your axis is horizontal, meaning the ellipse is kind of like this way, okay, then you'll have this format where you have x minus h squared, y minus k squared, which should look familiar. That's kind of like a circle, but it's divided by this length a squared, and this one's divided by this length b squared, where a is the distance of my major axis. Okay, so now I'm going to show you some pictures of what that looks like. But basically, if this was my ellipse right here, this piece right here represents A, and this piece right here represents A. So we have 1A plus another A is 2A, and that's where this distance 2A comes from. So whatever that number is, that's A squared, goes here in our formula, okay? You have the same thing for B. B would be the other part, so it'd be the smaller part here, B, and that's why we have a length of 2B, again, respectively, where of course B is going to be less than A because, well, it's the smaller axis, yeah? And we have the same concept for the vertical ellipse. This one, the only difference is this ellipse is kind of like this way. It's going vertically. And you'll notice that the a square and b square swap places because in this case, we have that the b is, I'm sorry, the a is going to be the bigger one. So if you notice our ellipse is kind of taller on the y-axis, which is why our A, which is the bigger one, that's the major one. A is always the major one. It comes first, right? So it's the major one, which is why the A is now with the y part. So that's how you have to remember. If your bigger number is on the y, you have a vertical um, ellipse. If the bigger number is with the x, you have a horizontal ellipse. Okay. We also have I think a note here. It says the foci, which is again the two focus points, always lie on the major axis, and they are c units from the center, with c squared is equal to a squared minus b squared. So if we have the vertex or we have the length of the major axis, have the center, we can find the focus points by using this formula once we have our A and B as well, okay? We have some notes here at the bottom that say, if the center is at the origin, so that means our H and K are equal to 0, well, then the equations take these forms where it's a little bit easier. It's just x squared over a squared, y squared over b squared is equal to 1, and vice versa with the A and the B if, if the major axis is the other way. So, okay, again, this one is the horizontal, this one is the vertical. And then finally, you have some pictures here that just kind of show you everything all together. You have the horizontal one where if it's sideways, then just kind of how I showed you at the top, this is this distance from the vertex to the center is A. Same thing on this side. If you add these two up, you have 2A. The center from to the other minor axis is B. This is also B, so this is 2B. And again, this is if the major axis is horizontal. Um, Likewise, if it's vertical, well, now the A is going to be the taller one. So it's A this way, which is again 2A, and the minor axis is this way. The vertices will always be at the ends of A. So when it's asking for the vertex points or the vertices, you're looking at the endpoints of your major axis. Okay, and here I just have a note that says these are general orientations of the ellipse. All right, that's enough notes. Let's go ahead and start doing some examples. We do have 3 examples. The last one is done for us. Example number 1. It says find the standard form of the equation of the ellipse with foci 2, 0 and 2, 6 and major axis of length 8. So what we're going to do with this one is we're going to actually just graph it first and see what it looks like. Yeah. So let me see. I have 2, 0, 2, 0. Okay. Yeah, I'm just kind of trying to visualize where I'm going to put this here. So I have 2, 0. So there's 2. And 2, 6. So let's see. 1, 2, 3, 4, 5, 6. And I might have to go a little bit higher, I think. Let's subdivide these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, because I think we're gonna have to do a bit more. So we have one at 2, 0, one at 2, 6. So 1, 2, 3, 4, 5, 6. There we go. So about right here. And this is the 0.26. This is the 0.20. And these are the foci points, or the focus points. So they're not the vertices, or the focus points, the foci. And then the length of this is 8. So I know that the total distance of, remember this, since the foci are here, it's probably going to be a vertical ellipse. So I know that this is going to be a vertical ellipse. And I'm going to go ahead and write down the formula that goes with that because it's probably, I'm going to need it at some point. So let's see. The vertical one is x minus h squared over b squared plus y minus k squared over a squared is equal to 1. Again, where the a is the major axis and it's with the y because, well, we're going vertically. So that one should be the bigger one, the bigger axis. Okay, moving on. The major axis is a length of 8. So before I deal with that, I know that the center is between the two focus point and it's equidistant. So in other words, it's going to be the halfway point between these two. So since my point is going from 0 to 6, half of that would be 3, right? So, and just to be sure, I can go ahead and just count. So 1, 2, 3. 1, 2, 3. So yeah, it looks like our midpoint or the center of this is going to be right here at 2, 3. And that's my center. So I already have one of the things that I need. I need HK. So for my center, which again is HK, I have the point 2, 3. So I could just plug those into my H and my K at some point. Remember, I need to get this equation at some point, but I'll do that in just a bit. Let me figure out my A square and my B square now. I know that the total length of this is supposed to be 8, right? It's supposed to be 8. So far I have 6 points. I know that from 0 to 6, that's like a length of 6. So if it's supposed to be 8, I'm going to have to go up 2 more. So 8 here, maybe right there, 6, 7, 8. And then 2 more down here at -2. So all I'm doing is I'm trying to get this length of 8 that I need. And it looks like that's going to be it. This is going to be my vertex, one of them. And this will be the other vertex. And those points are, let's see, this one's 2, 8. And this one is 2, -2. So yay, I have one entire thing so far. I know that my major axis, okay, is a total of 8. So if I'm trying to get, remember the major axis is like the distance of 2a. Since my major axis is 2a, let me go ahead and put this down here to make it official. So since my major axis is equal to 2a is equal to 8, if I solve this, I get that a is equal to 4. So there's another part that I have. I need a, I need H and K, which I have, and now I'm just going to find B, okay? How am I going to find B? Well, I also know that I have this formula, right? I'm going to kind of swap over here again real quick. C squared is equal to A squared minus B squared, yeah? I know what C is. C is the distance from the focus to the center. So since I know that, so I'll kind of put a comma here. Since we know that C is equal to, what is C equal to? Well, it's the distance from here to here. So from this focus point, we can put F for focus if you want. These are both focus points. From this focus point to the center, it's 3 units, right? 3 and 3. So since we know that C equals 3 and A equals 4, because we just found it, we can find B. Okay, so we're going to do that. Let me write my formula. C squared is equal to A squared minus B squared is the one we're going to use. And I guess I should kind of section this off like this. But I want B, so I'm going to solve for B. So if I move, let's see, if I move my, what am I going to move? I'm going to move the B squared. If I move the B squared, then I'll have C squared plus B squared. You can do this if you want. You want to kind of follow the steps. Is equal to A squared. And that makes my B squared positive. So now I'm going to go ahead and subtract C squared from both sides. And that would give me, that's 0. So B squared is equal to A squared minus C squared. And that's kind of what I want because I need to figure out what B is. So now that I have this, I can go ahead and plug everything in. So B squared is going to be equal to 4 squared minus 3 squared, which is 16 minus 9. And 16 minus 9 is 7. So B squared is equal to 7. And I mean, I guess I could actually kind of leave it like that because that's what goes in the formula. But if you want, we can square root it. So B would be equal to the square root of 7. Okay, now that we have everything, we can go ahead and write down our equation. Yeah, we have B, we have A, we have H, and we have K. So that's all we need. So let's go ahead and write this out now. My equation for this in standard form would be x minus 2, because that's our h, over b squared, which is going to be, get this a little bit straighter, which is going to be the square root of 7 squared, and we'll fix it right now, plus y minus 3 squared over my a squared, which is 4 squared, is equal to 1. And of course, you do want to simplify it. So let's write it nicely now. So x minus 2 squared over the square root of 7 squared is just 7 plus y minus 3 squared over 16 is equal to 1. And we are finished. Yay. Okay. And I think that's all we needed to find for this one, though. Let me just double check. Yeah, that's all we needed, the equation. So there you go. There's the answer for example 1. Okay. Let's go ahead and move on. We have one more example we're going to do together. And then the last one is you can kind of get a glimpse of this already done for us because it is kind of a lengthy one. So example 2, this one is to sketch the ellipse and identify the center and vertices. So we have the equation for this one. And what we're going to do is we're going to use it to try to figure out what everything else is. Okay, so let me kind of just make it a little bit darker. So it can come out so right here. To find the center, that's usually going to come from here. So just by looking at this, I can see that there's no parentheses. So my center is just 0, 0. Yeah. If you want to make a note for yourself, we have no parentheses. So it's kind of telling me that the center is 0, 0. Okay, so we have that. We already have H and K, which we're going to probably need at some point. Yeah. Oh, actually, yeah, we need these to the center. So the center is 0, 0. So we're done with one part. Yay. Yay, yes. How are we going to find the vertices? Well, to find the vertices, we need to figure out where everything else is. What is my A? What is my B? So I can maybe graph it and see, where those endpoints are going to be. So let's go ahead and rearrange this a little bit. So we have x squared plus 9y squared is equal to 81. Remember that this is supposed to be equal to 1 for ellipses. So we have a problem where we have this 81. We're going to divide everything by 81, like so. And that's going to give us x squared over 81 is equal to, I'm so sorry, x squared over 81 plus, this one's going to simplify, right? 9 over 81 is the same as, that's just a y there, 1 over 9. You can reduce it to a ninth. Okay, is equal to 1. So essentially what we have now, we kind of have what we wanted, the format. Remember that this part right here and this part right here is just something squared. Since this one is bigger, then this is going to be our A square, the major axis, and this one's going to be the B square. So what square is 81? Well, 9. So from here I can do it this way. X squared over 9 squared plus y squared over what times what is 9? 3. So 3 squared is equal to 1. And why do I want it in this format? Well, because this gives me A and this gives me B. So from here I know that A equals 9 and B equals 3, which means that for this one, 2A is going to be equal to 18 and 2B is going to be equal to 6, which is our major and minor axis points, or just lanes, I should say. Okay, so let's go ahead and use that to graph what we know so far. I see that the major one is on the X now, so that means it's going to be a horizontal ellipse because the major one is on the X. So let's go ahead and sketch that real quick. We have, let me see, my vertex is at the center. So maybe I have something kind of like this. 0, 0, 0. I'm not the vertex, I'm sorry, the center is at 0, 0. And since my A is 9, that means that I'm going to go 9 over this way and 9 over this way. And this is supposed to, remember this whole thing right here, that's 1A and this is another A, which is a total of 2A. My minor is going to be 3. So 3 here, negative 3 here. And again, this distance right here is B. This one is also B. And we can kind of, do our lips already. We can do, mine's kind of crooked, but it's going to look something like that. Okay. And you'll notice that at this point, we have the vertex points. We have one vertex is going to be 9, 0. The other vertex is going to be negative 9, 0. Yeah. And we have part of the answer. Actually, That's all we needed. We had to sketch the ellipse, identify the center and vertices. So there you go. There's one, there's two, and the center was 0, 0. Easy, easy problems, guys. Easy problems. Happy face. All right. Okay, last problem. This one is a little bit more complicated. I went ahead and solved it just because of time. So let's go ahead and look at this monster of a problem. Let me see if I can cover some of this. Let me use my music paper here. We have example 3. We're going to have to complete the square for this one. It says, find the center, the vertices, and the foci of the ellipse of the following. 9x squared plus 4y squared plus 36x minus 8y plus 4 is equal to 0. We also have to sketch it. Okay, so crazy problem. Here's the solution. We are going to complete the square for this one. And it's kind of an interesting one because you have to complete the square for both the x and the y components because you have two things that are being squared. So how do we do that? Well, we first rearrange this and we move the constant. So we're going to put the x's together and the y's together. And then that plus 4, I'm going to move it over. So now it becomes -4. And that's what the first step for completing the square is. You fix it to where it's in a standard form, and then you move the constant. In this case, our standard form is, this part right here. It still doesn't look like a standard form, though. We have to factor something out. So we're going to factor out the 9 from this part and the 4 from this part to give us that x squared plus x, y squared minus y. Okay, so that's the next part in this. Then is the square part. So we're going to put this box here because this could be a perfect square if I had a specific number here. Same thing with this one. If I had a specific number, it could be a perfect square and I could factor it as a binomial squared. And if you put two boxes here, well, you got to put two boxes on the other side. Okay, so there's that double complete the square part. Here is the actual square that we're going to be calculating. So for step number 3, and I did kind of label them 1, 2, 3, by the way, in case you want to, do it as steps. I'm taking my b, so my b is 4. Oh, no, it's not focusing. 1 second. There we go. I took my b, so 4 divided by 2 is 2. 2 squared is 4. So this is what I'm going to plug into that box. Same thing over here. I took my b, which is -2. -2 over 2 is -1. -1 squared is 1. So again, that's going to go in this box. And then you have this be careful thing. So let me go ahead and explain this part because this part might throw you off a bit. You'll notice that we did put the 4 here and we did put the 1 here, and we also put it on the other side because whatever you add to one side, you have to add to the other, right? So there's the 4, there's the 1, but since we had a factor in the front, 9 and the 4, you're going to have to put those factors for these two because you're not just adding 4, you're doing 9 times 4. You're not just adding 1, you're doing 4 times 1. So we have to include that on my other side over here. So just be real careful with that. After that, it's a matter of just simplifying. So you'll notice that we kind of rewrote this. This part is factored to x plus 2 squared. This is y minus 1 squared. I brought everything down. Over here, I just multiplied everything out. So -4, 36, and 4. You'll notice that on the next step after that, it says factor and combine. This is all the same. Here, I just kind of simplified this. -4 and 4 is 0, so I'm left with 36. And at this point, it kind of looks like the previous example where you have to divide to get the 1 over here. So I'm basically kind of done at this point, and we begin the standard form part where we can rearrange it. So begin standard form. How do you do that? You divide this by, well, everything by 36. So I did that here, 36, 36, 36. Simplify it, and voila, we have the answer. So this divided by itself is 1. 4 over 36 is 1 over 9. 9 over 36 is 1 over 4. Notice that those parentheses are just the same. And this is kind of what we wanted, but I'm gonna fix this to where it looks like, like this, so I know exactly what A and B are. You will notice that my A is on the Y this time because 3 is bigger than 2, which means this is going to be a vertical ellipse. Okay, and that's the last part I have right here. The center is going to be from these points, so the opposite, -2 and +1. The vertical major axis is 3 because that one's bigger. The minor axis is 2 because that's the other one. And I think that's kind of everything. Let me see. All right, so everything's kind of labeled here. We have our center, -2, 1. Since I know that the major axis is 3, you can see that I kind of counted 3 up and I counted 3 down, and that gave me the endpoints, which is also the vertex points or the vertices. So if I go 3 up, I land at -2, 4. If I go 3 down, I land at -2, -2. With my B, I go 2 to the right, 2 to the left, and though that gives me the other sides of the ellipse. And the last thing I need to find is the foci, because they are asking for the foci. Remember that the foci is C spaces away from the center. So I did use the formula for this one because it's not quite obvious where it's going to land. So you have to use the formula. So just plug it in. C squared is equal to A squared minus B squared. 3 squared minus 2 squared is basically 9 minus 4. So I have C squared is equal to 5. So C is the square root of 5. So that means that my focus point is going to be somewhere square root of 5 units away up here, which is, I have no idea, probably like 2 point something. So it's about 2 point something units up. So 1, 2, maybe like right here somewhere. And this one is 1, 2, like right here somewhere. I don't really know what it is exactly, but I do know that the x value is -2, which is what I have right here, -2, -2. And the y value is going to be, well, whatever the y is here, plus square root of 5, and then y minus square root of 5. So that's what I have here. And that, ladies and gentlemen, is the end of this set of notes. If you have any questions, as always, please reach out, let me know, and I will be glad to help you.